Hello coders, let's start week 3 of LeetCode April challenge. Problem for today is array self, product of array except self, and I remember from the title, I remember the problem. So maybe this week let's try not measuring the time. I will not run the timer. Of course you can yourself check how many minutes or seconds it took me to solve a problem. I will be maybe more calm and explaining. For this problem I will first solve it, implement it, and then do some drawings maybe as an extra. We'll see. And my face will be better on the left. Given an array nums of n integers, or n is at least 2, return output such that output of I is equal to the product of all elements except nums of I. So if you look at this, this number is 8 because it's product of all numbers except for this one. I can make it slightly greater. Slightly bigger. 1 times 2 times 4 is 8. If you look at this position, product of all other numbers is 1 times 3 times 4, 12. So this is 12. And this problem becomes easier if there are no zeros on the input. Because we can compute product of everything, it's 24. And then product of everything except 3 is product of everything divided by that. Let's start with this, but it's not correct because there might be zeros, at least I believe so. Nothing is, I think, guaranteed here. But let's try that. Product. Product of everything can exceed maybe int type. They here say that, including the whole array, fits in 32-bit integer. So I can use int. Product is 1, iterate through everything and multiply. Then create an answer vector or array of size n. I like to create variable n as nums.size. And what now? For every position, answer of I is product of everything divided by nums of I. Return answer, and I expect this to fail because there might be zeros. If I run code, pending, this I believe is correct, but when I submit I should get runtime error because of dividing by 0. Yeah, for example, input is 0, 0. There are two major ways to fix that. First is to realize that product of everything except for one element consists of two parts, left part and right part, prefix and suffix. And there are methods for that called prefix sum and suffix sum. Actually here those will be products. So I can create vector of int prefix product, initially just put 0 there, no, not 0, 1, push back 1, and then for every element in nums, prefix product, append the previous element times x. So it will, for this array, prefix product would be 1 for empty prefix, then times this 1, 2, 6, 24. And the same for suffix. Suffix product. Maybe I will create that in slightly different way. Suffix product of n is 1 for every position. It isn't that convenient to create suffix sum or whatever. Suffix product of I is bigger 1 times this new element. So I start by saying from n to the right, the product of everything is 1 because it's empty suffix. And then going backwards, I compute those. Suffix product is product of everything starting from position I to the right. Those are two different methods of computing those stuff. Like I could use this method also with indices to do that, and the other way around, but it would be more complicated. And now, let's remove that incorrect solution. Answer of I will be, well, it consists of two parts. Prefix up to something times suffix up to something. Like from something. Let's first this. I claim that when I'm looking at position I, I'm interested in things from I+1 to the right. What about this? This is trickier because of how I created that. And the thing with prefix sums is that it's hard to avoid -1. I will say that this is the thing I need. Because I claim that prefix of I is, maybe without comment first, prefix of I is equal to a of I times a of I -1 times and so on times a of 0. For example, because first I put 1 as empty prefix. So in particular, prefix of 0 is just a of 0, according to this formula. Right? And this is incorrect. What I want to say, prefix of 0 is nothing. Prefix of 1 is just a of 0. Prefix of 2 is just a of 0 times a of 1. So prefix of I is product of everything till a of I -1. That's important. So if I want here to say that I need a of I -1 times a of I -2 times and so on times a of 0, this is exactly that, pref of I. So hence this. You need to choose some method to compute prefix sums and so on, products, and then stick to those indices. Understand what holds what. I can comment this out, and I believe this should be okay now. Notice that I avoided division. I'm interested in product being product of two parts. Use of undeclared and pref. I should use the full name, prefix product. And similarly, suffix product. Run code. This will be O of n space and O of n time. I only have single for loops, so nothing is quadratic. No for loops are nested within each other. This should be accepted, but there is a challenge here. Follow up. Could you solve it with constant space complexity? The output array does not count as extra space. So I can create this time this answer, but I cannot create anything like that. Some small exercise for you is to take this code and try to avoid the second array, suffix product. It is possible. If you compute array prefix product, then as you go through the array, you can compute all the answers. This array is not necessary, then you decrease the memory used from n plus n to just single n, plus obviously we need to store the answer anyway. So that's an exercise for you. But what I want to do now is solve it in constant space complexity. How to do it? Let's get back to our first solution, where I compute product of everything. And it fails, for example, if the array is 1, 2, maybe let's say 2, 2, 0, 3, 4. Because then product of everything is 0. And actually, like for every position, you will say that it's 0 divided by 3, here 0 divided by 0. If you want to say product of everything divided by myself, by this number, nums of I. And if myself is 0, then it's runtime error. It will not be correct. What should be the answer though for this? It should be, I claim this, 1648, 0, 0. That is the answer. If you look at this position and want to compute product of everything else, it's 0. For this position, it's 48. So let's try to, for 0, compute product of everything else. If there are two zeros in the array, if the input is 2, 0, 2, 0, 3, then answer is just zeros. So there are just cases, special cases. I can compute product. We are getting back to the first solution, kind of. I still want n. Constant is a good thing in C++, but not a must to force a variable to not be changed. Product is product of everything. Product times equal x. And what do I want? If product is not 0, this means all numbers in the input were non-zero. So I can use my first solution. Actually, I will create answer once of n This is array of size n. And here, for every position, answer of I is product divided by nums of I. Else do something, and at the end return answer. I will get rid of all of that. Don't need it. What if it's 0? If there were at least 2 zeros in the array, then I want to return just zeros. Otherwise, as we had for 22033, I need to compute for 0 the product of everything else. It would be 2 times 2 times 3 times 3. So what about this? I can have count zeros, maybe. If x is 0, then count zeros plus plus. At the end, it might happen that I realize, oh, some if is unnecessary. Something is unnecessary. Maybe I can do it without that. But I noticed I can do it, and it will not give me a complicated solution, so let's go that way. Else, if count zeros is equal 1, if there is just 1 0, that's a special case when I need to compute product of everything else. Else, more than one zero, answer, actually do nothing. Initially, like if you create vector of ints, by default all values are zeros, and that's correct answer. So here, do nothing. Do nothing. I don't need to handle anything. I need product of things other than 0. What about computing this now? Product of non-zeros. So if it's not a 0, product of non-zeros times equal x. Else, what do I do? Answer for this single 0. So let's find it. If nums of I is 0, answer of I is product of non-zeros. And this should be enough. I just analyzed cases and thought what is best in which, what should be done in which case. Submit. But on the other hand, those solutions are dangerous. I have 3 separate parts of logic, and if I make mistake just in one, it's already bad. I incorrectly handle a case of single 0. Let's see that. If nums of I is 0, then this is product of non-zeros. So I computed product of non-zeros incorrectly. Let's think. If not 0, then multiply, but I initialize incorrect. If you want to compute product of things, initially you need to use 1, because 1 is neutral element for product. You need to start with 1 if you want to then multiply by things. If you start with 0, it's all bad. This is accepted. I will maybe make one more drawing for what happens for this case, like what are prefix sums and prefix products and suffix products. And also I have 15 seconds left to do anything with this problem. This video will be a little bit late, but I hope it's fine for you. Just some small analysis of prefix products and suffix products. With prefixes, I start with 1, denoting product of empty prefix, then multiply by every next element, 2, 6, 12, times 5 it's 60. Those are prefixes. Now going from the right, I choose suffixes. For empty suffix, it is 1. Empty suffix and empty prefix, they just help you, because later when you say, okay, what is the answer for this number? You want to multiply product of things on the left, so empty prefix, with this. This is why I need something for empty. Otherwise I would need ifs anyway. Suffixes, 1, 5. I go from the right and multiply by every next number. 5 times 2 it's 10, times 3 30, times 2 it's 60. By the way, this number and this number, they must be the same, because it's the product of everything. And when now I want an answer for, let's say, this 3, I want product of this times product of that. This up to position I hold it here. So if this is my I is equal to 1, I see, for example, for this I, that I need to take prefix of I, this is the same position, This is position 1, 0 based. This is position 1. And to get that, I want 10, this one. And this is suffix of I plus 1. I can get this by looking at the example and seeing which index I need, or by analyzing. Prefix of I was prefix a of 0 times a of 1 times up to a of I minus 1. I'm not saying that this is very convenient and best method to index prefix and suffix products, but it's something. And there is nothing to analyze for that other case with zeros, because it just ifs and you saw what they did. I think this is everything. Thank you for watching. See you tomorrow. And again, I will try to do this week without timer. Tell me in the comments if you think that's a good idea or you really want it back. That's it. Have a nice day or evening, night. Bye.